In this episode, we'll talk about the diesel particle filter, also known as DPFs, and their essential role in the containment and transformation of the dangerous solid particles that travel along the exhaust line with the combustion gases of our diesel vehicles before those gases go into the atmosphere. Walker, with 63 manufacturing plants distributed throughout the world and 8 engineering technical centers, is one of the largest emission control manufacturers, both for the original equipment and for the aftermarket. Walker is also one of the pioneering companies in the development of DPF particle filter systems for passenger vehicles. To guarantee the maximum level of performance of the engine with the minimum consumption, Walker takes special care of the back pressure and noise level of its products, making sure that all the range of emission control products is homologated, following the strictest environmental regulations required in each case. In order to get a good understanding about diesel particulate filters, their types, how those units are built, and their important role in the emission control system, we have prepared for you the following video. Description and operation. The strict directives imposed by international administrations are forcing manufacturers to develop extremely diverse and advanced technologies in the area of emissions control, especially for diesel engines. In combination with other systems like catalytic converters or the recirculation of exhaust gases, the particulate filter is key to reduce and convert some of the pollutants present in exhaust gases into substances that do not harm humans or the planet. The following video tutorial aims to facilitate diagnosis of the particulate filter and related parts of the engine control unit. What is a diesel particulate filter? The diesel particulate filter, also known as the DPF or FAP in French, is an exhaust system component primarily found in diesel vehicles after 2005, although some brands like Peugeot installed it in many of their models starting in 2002. Its function is to retain and accumulate solid particles present in exhaust gases to keep them from being released into the atmosphere. Because of its size, they are trapped inside the filter, while gases that have already been catalyzed pass through the porous walls through the exhaust pipe. When there are enough accumulated particles inside the filter to make it hard for the exhaust gases to pass through, the control unit works, starting the regeneration process. The active regeneration process consists of increasing the temperature of the exhaust gases to an average of 550 degrees Celsius. Then the solid particles retained by the filter, mostly composed of carbon, oxidize, combining with the oxygen in the exhaust gases. The process transforms the solid particles into carbon dioxide, which, since it is a gas, can escape through the porous walls of the filter with the already catalyzed exhaust gases into the atmosphere. Since all oxidization processes also release large amounts of heat, this helps regeneration continue once it starts. The filter regenerates regularly every 400 to 800 kilometers under the right conditions, so the process goes unnoticed by the driver and in no way limits the use of the vehicle. Today, particulate filter systems can be divided into two major groups: those that need an additive to perform the regeneration process and those that don't. The additive system injects a fluid based on cerium in the fuel tank, whose molecules adhere to the solid particles that travel with the exhaust gases at the combustion chamber. The cerium adhered to the soot lowers the temperature necessary for the combustion by approximately 100 degrees Celsius, reducing the time needed to perform for a full regeneration of the filter and the temperature in the exhaust system. Morphologically, there are 4 major types of particulate filters on the market. The first has a detachable catalytic converter and is built separately from the particulate filter. In the second type, the catalytic converter and the particulate filter are separate but are part of the same housing. In the third, there are particulate filters that have a catalytic converter and a coated filter, but are installed far away from the manifold. In the fourth type, there are so-called closed-couple DPF that are installed at the exhaust manifold and are built with catalytic converter and coated filters included in a single housing. Those are used in vehicles that, because of their design, have trouble reaching the temperature to start regeneration. In this last type, the catalytic converter and the particulate filter are part of a single structure and cannot be physically differentiated from each other. Frequent symptoms and problems with the particulate filter. The main problem particulate filters have is when the vehicle makes short trips, usually when driving in cities and with the engine cold. During those drives, the temperature, workload, or time conditions are not ideal to undergo a complete and effective filter regeneration. So buildup grows on the filter, making it harder to discharge the exhaust gases and correctly fill the cylinders. After a certain amount of soot has accumulated, approximately 30 grams, or a 46% obstruction of the filter, in some vehicles, a light will come on the dashboard to let the driver know he or she needs to complete a driving cycle for a full regeneration. Usually, driving half an hour with the engine at working temperature at a stable speed over 80 km an hour with intermediate RPMs should be enough. If this is not done, soot will build up on the filter, making it hard for exhaust gases to exit. In extreme cases, this can cause the engine to malfunction and performance will be affected. When the filter buildup exceeds 76% of capacity, the dashboard will show one or more warning lights and the engine control unit will manage it in the degraded operation and reduced performance mode. Issues with some mechanical or electronic parts of the engine can prevent the filter from correctly regenerating or even prevent the process from activating. In this case, the engine control system should be repaired as soon as possible, or the vehicle should not be driven. Regardless of the previous warnings, if the particulate filter system has fuel additives, a warning light will go on if additive is low. If more additive is not added in a predetermined prudential amount of time, the vehicle will activate a protection strategy, trimming performance at first and, as a last option, preventing the engine from turning on. Active regeneration and saturation control. The engine control unit calculates the saturation of the particulate filter through programmed calculation models taking into account several real as well as theoretical parameters related to the vehicle's operation. One saturation calculation model is based on the type of driving. If the vehicle is being driven on an open highway, the exhaust gas temperature will be high and a few particles will build up on the filter. The length and average speed of trips, the engine's temperature and workload, and the amount of fuel injected are considered to calculate the theoretical saturation of the filter. The parameters for the engine and exhaust gas temperature sensors, the vehicle's speed, the air mass and the fuel consumed, as well as information on the lambda sensor if there is one, are essential for the calculation. The second saturation calculation model is based on measuring the resistance of the particulate filter to the flow of exhaust gases, creating a pressure difference between the intake and the exit of the filter. The degree the particulate filter is saturated is calculated by assessing the difference in pressure based on the engine RPM, the temperature of the exhaust gases, and boost pressure. For this calculation, the main inputs are the signals for differential pressure, engine and exhaust fume temperature sensor, and boost pressure. Active Active regeneration process. After running the corresponding calculations, if the particulate filter is saturated enough, one way or another, the need for active regeneration is determined and memorized. As a result, the control unit of the DPF system activates, if the operating conditions allow it, different resources to raise the temperature of the exhaust gases and start the regeneration process. If the conditions are not right during the active driving cycle or the regeneration process is paused after starting, the unit will initiate it in the next operation cycles. To increase exhaust gas temperature, the engine control unit activates the glow plugs and specifically controls the fuel injection system, the turbocharger system, and the exhaust gases recirculation system. Air intake is regulated by the intake manifold butterfly, partially closing it to reduce the amount of fresh air coming in from outside. In some vehicles, there is also a bypass system that overrides the air intake through the intercooler. This prevents momentary cooling of the combustion chamber and of the exhaust gases when the engine workload drops. Exhaust gas recirculation is deactivated to increase the oxygen in the combustion chamber and the exhaust line. This raises the peak combustion temperature, thus increasing the temperature of the gases arriving at the filter. In some systems, the turbocharger pressure is regulated more aggressively to heat up the air between the turbo's blow-down turbine and the intake manifold butterfly. Then the fuel injection system is acted on. Soon after the main injection, there is a first post-injection, around 35 degrees beyond the top dead center, to increase combustion's final temperature. One or more post-injections occur in the exhaust phase. The fuel injected while the cylinder is emptying is not burnt in the cylinder. It is vaporized in the exhaust line, fully mixing with the gases as it goes past the turbo's exhaust turbine. The gasified hydrocarbon oxides inside the catalytic converter, releasing a huge amount of heat that increases the temperature of the soot built up on the particulate filter. Additive dosage system. The DPF system includes a fuel additive circuit. The level of cerium in the reservoir and its dosing system must be controlled carefully. If there is a lack of additive, the carbon particles will not oxidize, since the regeneration program provides for a temperature increase of the particulate filter up to 450 degrees. That is 100 degrees less than what a system designed for working without additives needs to oxidize the carbon particles. I hope you found the video interesting, giving you a better understanding of the diesel particulate filters and its important role for our actual emission control system. In the next episodes, we will be able to study how to perform a good step-by-step diagnosis of the DPF system using an auto-diagnostic tool. If you are interested in the maintenance and service procedures of DPF systems, don't miss the opportunity to watch it.
We are Garage Gurus. Join our community. Follow us on social media. Thanks for watching this video. The video description contains all the relevant links. Don't hesitate to like, subscribe, and be notified when we post new content. Also, check out our Garage Gurus online course catalog.